Welcome to ShowMe number 9. This one's about parallel and perpendicular lines, particularly their equations and the relationships of their slopes. For two lines to be parallel, the pair of lines has to meet two conditions. First of all, the two lines have to be on the same plane. Well, that's pretty easy for the context of this chapter. Everything we're doing is on the coordinate plane. That's one plane, so the lines we talk about will be on the same plane. The second condition is that they must never intersect. They can't have any points in common. If those two conditions are met, we've got parallel lines. Let's think about what it means for that to happen, though. If two lines on the same plane never intersect, that means that they are both headed in exactly the same direction. What number, what quantity that we're familiar with, describes the direction of a line? Only one thing describes the direction of a line, and that's the slope. If two lines are going in the same direction, they're going to be parallel. Well, that means that if two lines have the same slope, they're parallel. That's a very important idea. Parallel lines always have the same slope. There are two conditions that are sufficient for a pair of lines to be perpendicular. First of all, they must intersect. And since they're intersecting, they'll be on the same plane. The second thing that has to happen is that at the intersection, they have to form right angles. They actually form 4 of them. So perpendicular lines form 4 right angles. Let's get a picture of what this might look like. Let's say we have a line whose equation is y equals 5x plus 1. Okay? It's going to be a very steep line that has a y-intercept of 1. Something like that. What would a perpendicular line to that look like? Well, it's got to come in and intersect with it at a right angle. It might look something like that. Now, our original slope was very steep. Our new slope is very flat. Our original slope was positive. Our new slope is negative. So, the slope for the perpendicular line is going to be of an opposite sign, and it's going to be significantly smaller in magnitude. That's all you can really tell from the picture. The fact is, if we have two perpendicular lines, their slopes are what we call negative reciprocals. To find a negative reciprocal, take the slope you've got to begin with, rewrite it as a fraction if it isn't one already. Then, flip it to give its reciprocal, and then take the opposite of that to get the negative reciprocal. So if a given line has a slope of 5, the line perpendicular to it will have a slope of negative 1/5. That's what we mean when we talk about negative reciprocals. So if two lines are perpendicular, the slopes, the directions in which they are going to have this particular relationship. They're going to be negative reciprocals. 2 problems grow out of this information, and these are problems that will be very important. You'll be expected to know how to do them not only in your school courses, but also on standardized tests. In these problems, you'll be given 2 pieces of information. The first one will be the equation of a line. The second piece of information will be the coordinates of a point not on the line. Given that information, you'll be asked to find the equation of another line that is either parallel or perpendicular to the given line that goes through the point. These problems are common, and they're going to be the special focus of my next two examples. I'll do one with parallel and one with perpendicular. So for the first example, we're given these two pieces of information: the equation of a line, y equals negative 2/3 x minus 4, and the coordinates of a point, 2, 7. Our task: find a line parallel to the given line that goes through the given point. The ideal equation of a line to use for this kind of problem is the point-slope form. Go ahead and write that down now. Y minus y1 equals the slope times the quantity x minus x1. This is the point-slope form of a line. Given the information we've got in front of us, we're ready to write the equation right now if we use this form. Remember that x1 and y1 are the coordinates of a point that are on our new line. Well, we know that 2, 7 is on the line, so we know that y1 is 7 and x1 is 2. M, of course, stands for the slope. These lines are supposed to be parallel. Parallel lines always have the same slope. So in this case, m is going to be negative 2/3. The rest of the equation stays as it is. And there you have it. Graph that line. It'll be parallel to the line we started with, and it will go through the point 2, 7. It really is that simple. A lot of times the problem will also specify a certain form for your result. You should be able to quickly convert this into slope-intercept form or standard form if you're asked to do so. Our second task is going to be to find the equation of a line perpendicular to the line represented by y equals 4/5 x plus 8 that goes through the point 3, negative 1. Again, the ideal equation to begin with is our point-slope form. Y minus y1 equals m times the quantity x minus x1. Once again, we've got a point already. We've got 3, negative 1. Plug those into the appropriate places. For the first part here, we're going to have y minus y1. That's y minus negative 1. Subtracting a negative usually ends up looking a lot like addition. So well, in this case too. So you have y plus 1. x1 is 3. That'll still look like subtraction. Now we come to the issue of the slope. These lines aren't parallel, so they're not going to have the same slope. Their slopes are going to be negative reciprocals. Take 4/5 and invert it, creating its reciprocal. And then take the opposite of that, and we have negative 5/4. That's the slope of a line perpendicular to the given line. And there we have it, the equation of a line perpendicular to the given line that goes through the given point. So let's review. Parallel lines always go in the same direction. The number that describes direction on the coordinate plane is slope. Parallel lines always have the same slope. If you have two parallel lines and you know the slope of one, you know the slope of the other, you can use that information to discover the equations of other lines that are also parallel to the given lines. Perpendicular lines have slopes that also have a special relationship. They can't be the same slope because the two lines that are perpendicular must intersect. The relationship between the slopes of perpendicular lines is that the slopes are what we call negative reciprocals. That means that if you know the slope of one line, you need to, wow, wonderful spelling. Let's try that again. There we go. If you know the slope of one line, you need to discover its reciprocal by writing it as a ratio and then reversing the numerator and denominator, and then take the opposite of it, and you'll have the slope of a line perpendicular to the given line.